everyone, and welcome back to the Encrypt Coding YouTube channel. I'm Nandita, and this is our introduction to the object-oriented programming paradigm. This is part of our Java series, so please like, comment, share, and subscribe, as there'll be many more videos like this. At the end of this lesson, we will learn how to comprehend the meaning, necessity, and usage of an object-oriented design, to define what exactly is object-oriented programming software, and to identify the steps behind the object-oriented programming software, to interpret the four principal components of such a software, to list the advantages, and to identify the principal terms class and object. Now, what is object-oriented programming? Object-oriented programming is a type of programming paradigm. Now, what is a paradigm, you might ask? It's a concept by which a methodology of a programming language adheres to. Paradigms are really important because they define the programming language and how it works. So a programming language aims to solve a certain problem, and a programming paradigm shows us the way how to solve a certain problem, a certain methodology, which makes us a lot competent in solving a certain problem. Now, object-oriented programming is a computer programming model that organizes design around real-world entities or certain data called objects, rather than the logic behind those data and functions related to that data. Now, examples of object-oriented programming languages include Java, C++, Ruby, Python, and Perl. As you can see, many of the most famous programming languages all rely on object-oriented programming. Now, what exactly is the need for object orientation? Object orientation reduces complexity of programs as it focuses on the objects that developers want to manipulate rather than the logic required to manipulate them. This approach is well suited for programs that are being actively updated or maintained and are very large. It's a new approach to software design that has become a necessity due to the complexity of software development. And maintaining and managing software has now become a lot easier. About collaboration, the organization of an object-oriented program makes the method beneficial to collaborative development, where projects are divided into groups. Now, relatability. Since object orientation involves the representation of real-world entities and real-world objects in the software, it is a lot more relatable to us humans and basic developers. Now, what exactly is an entity? An entity can be described simply as a living or non-being that exists in this world. Now, what exactly an entity contains is what is very useful for software. An entity contains its own attributes, which is a set of characteristics that describe it, its unique identity, and its descriptions, physical appearance, and in case of living organisms, its mental appearance. An entity also contains some behaviors which may or may not be common with other entities of the same type. Now, these common behaviors are a state of an entity, which may change. Now, attributes in the real world are represented by data members in Java. Now, what exactly is a data member? A data member is also known as an instance variable. Now, this instance variable is represented as class variables in Java. They are not contained within a function and they are declared outside all functions but within a certain class. Now, this behavior of an entity, which represents functionality, it is represented as functions or methods in Java. An entity can exhibit multiple behaviors, hence multiple functions can be used to change the appearance or the attribute of an entity. Now, this is an example for an entity. What you can see is a very famous book called Wonder. Now, this is an entity and it has its certain attributes. For example, the author, the ISBN number, which is a unique identification number for a certain book, its title, its color, and many other attributes. Now, it's also got its common features or common behaviors, which may be common to other books or may also not be common, such as buying, selling, reading, and writing. And these can be represented as functions in Java, while the attributes as instant variables or data members. Before doing object-oriented programming, it is very important to do an object-oriented analysis. This is very important since it gives a clarity to the programmers to identify the important parts of a program, and it also makes it easier for the programmers to implement those parts. Now, the steps for analysis include: step 1 would be identification of all the entities involved in a problem domain, because the entities are the most important part of an object-oriented program. Step 2 would be defining the attributes of all the entities. Step 3 would be analyzing the behavior of the entities, while step 4 would be to identify the relationship between the entities. And this is how we conduct an object-oriented analysis. After we list all of these entities and their attributes, behaviors, and the relationships, we list them down and then we keep it aside to implement them in our object-oriented program. The class is very, very important in an object-oriented programming language. For now, we are taking Java as an example since this video is part of our Java series. But this also implies to other object-oriented programs as well. Now, what exactly is a class? In the Java programming language, a class is a keyword which is used to form a blueprint from which objects are created. It does not occupy any space in the memory. It only contains the instructions necessary to create an object. What does it represent in the real world? A class represents a certain entity. That's why the contents of a class would be data members, which contains the attributes of the entity, and functions, which contain the common behaviors of an entity. An example of the class would be string library class, which is a class already available and pre-written in Java. Now, in this class, we've got certain attributes such as the length of the string, which is stored as a data member in this class, along with functions. For example, to convert all the characters of the string into uppercase or lowercase. Now, what exactly is an object? An object is an instance of the class. It is a sample or an example of the class. Now, this object is created from the class itself, from the blueprint, when the program executes. It can consist of variables and arrays, and this is allocated space in the memory, unlike the class. From any given class, any number of objects can be created as per the programmer's requirement. It is the core of this programming paradigm. For example, objects created using scanner class. To create an object, we always use the new keyword, which is the identification for the creation of a new object. Now, these are the most important 4 features of an OOPS language. Just for your knowledge, OOPS is just an abbreviation for Object-Oriented Programming System or Object-Oriented Programming Software, however it is used. So the 4 features are abstraction, encapsulation, polymorphism, and inheritance. First, we'll talk about abstraction and encapsulation, since these two features go hand in hand. Abstraction is a feature which facilitates a simple showcase of only the most important, essential, and relevant details of a software program. Essentially, it's a process of selecting or removing certain information from a larger pool of data and selecting only what a certain program needs and only showing the selected certain important details. This increases efficiency and reduces complexity. One of the advantages is that you can apply the same information to other applications with no modifications because you already selected what information is useful for you. Now, encapsulation is an extension of abstraction. Now, both abstraction and encapsulation, as said before, go hand in hand. It's a feature which hides complex and difficult to understand details and implementation techniques from the users. And it presents a certain program in a way that it looks seemingly simple. So essentially, encapsulation facilitates data hiding, or when certain objects and data maintain a private state. Therefore, other objects and other classes cannot access this information, and the information is hidden. Now, one simple real-life example would be the communication of dogs. Now, the meaning of the communication of dogs, or what they imply and the information that they pass from one another, is hidden from us humans and other species, and it's only communicated between the dogs. Essentially, it is private to us. It's a similar case for all other communication of animals. Now, what is polymorphism? Polymorphism is a feature which allows a single object or a single function to show different and diverse behaviors with different outputs. So essentially, a certain function can give a different output with different inputs and different parameters. So essentially, there's no confusion in mixing types. You can put whatever type you want and with the same function name, and you get your desired output. So there are two types of polymorphism: overloading and overriding. Overriding will be discussed in the subsequent videos, while overloading might have been discussed in the function video. Now then you have inheritance. So essentially, inheritance is a feature where one class inherits or acquires some or all of its properties from one or more other classes. And the keyword used here is extends. So essentially, it's how a child inherits the traits of his physical or mental features from his or her parents. So essentially, the main function of inheritance is reusability. Now, what are the advantages of object orientation? The three advantages are that object orientation is extendable, maintainable, and reusable. When you say an object-oriented program is extendable, it is easier to add new features or implement new modules without making any major changes to the existing code. When you say that it is maintainable, a change in system requirements will generally not affect other parts of the code, or it will only require minimal modifications. It is also easy to communicate between objects, since there is an easy connection in the interface due to effective message and information passing techniques. When we say that object-oriented programs are reusable, as a software will be designed as components, it's always very easy to reuse a component in other software. And code can be reused through inheritance, meaning a team does not have to write the same code multiple times. Other advantages include productivity, security, and flexibility. Now these are the homework sums for practice. Like other videos, I couldn't get certain codes because this is a completely theoretical topic. But I hope these questions might invigorate your mind to think really well. Thank you very much and please stay tuned. This is Nandita signing off from Encrypt Coding.